a self-taught web developer. I'm also a software engineer at Eventbrite. You might know me as the creator of Human Wasteland, also known as the Poop Map of San Francisco. If you don't know what that is, come talk to me after the break. Or the creator of Developers, which is a dedication to Mr. Steve Ballmer. You can find that on my Twitter profile. So all of that is just like a long-winded way of saying that I write code for a living. So first off, some disclaimers for this talk. There are going to be a ton of animated GIFs. There might be some errors in my talk. So you might be a little bit like this while I'm speaking, but before you get a little bit more like this, let's talk about it. But let's talk about it after these messages. All right, so let's go. As I said, I am a developer, software engineer, programmer, or whatever else you might want to call me. So some days when I look at my computer, I feel like this. I don't even know what this means. And sometimes when I'm talking to other developers, I feel a little bit like this. Phil Carlton once said there are two hard things in computer science. Caching, validation, and naming things. And we can see that in various jargon that we have in computer science and web development. So here is just a sampling of words that really confused me over the course of the 3 years I've been a web developer. And when I've been in conversation with other developers, I sometimes ask, like, oh wait, could you wait just a second, can you tell me what that means? And then I get a look like this. And that makes me feel like this. So as I said, there are a lot of really complicated words, and they have really complicated histories, and that's all in computer science and web development. So I'm here today to kind of go over a little bit of this vocabulary and where it comes from, what things mean, and how we can better explain it to other people, so that you can feel a little bit less like Urkel here, and a little bit more like Brent Rambo. So to start off, parameter versus argument. What's the difference, and is there one? So of course, first things first, I went to Google. And you'll see that the third autocomplete down is argument parameter difference. So a lot of people have this question. So let's take a look at this function that I wrote. You'll see my function is called sharp. It's a little bit outdated, but the first line of the code snippet, you'll see the word side. And then at the bottom, the very last line of this code snippet, you'll see the string left.
So how many people think that the first line, side, is a parameter? Raise your hand. And then how many people think that it's the string left at the bottom of the function? Raise your hand. Okay, I'm not going to tell you yet, but let's keep going. So I decided to check on online etymology dictionary to see where the word parameter comes from. Etymology is essentially the history of words. So we see here that a parameter is a measurable factor which helps to define a particular system. And I was like, oh, that kind of makes sense for computer science or web development. But then I go to argument, and all I can find is information about arguing, which doesn't really relate to us for computer science and web development, I guess, unless you're talking about Vim versus Emacs. So I keep reading, and I decide to go check out Wikipedia and see what they say there. So under computer programming on Wikipedia, you see that the term parameter, sometimes called the formal parameter, is often used to refer to the variable as found in the function definition, while the argument, sometimes called the actual parameter, refers to the actual input passed. And I was like, oh, that makes sense. I think I understand what parameter and argument are and what the difference is. However, I was like, why don't we use the terms formal parameter and actual parameter anymore? And in order to figure that out, I had to go down the rabbit hole. And we took the red pill earlier, so I think this will be fine. So to start off with the rabbit hole, I found the definition in math, and you'll see that A function definition can also contain parameters, but unlike variables, parameters are not listed among the arguments that the function takes. I was like, what? Parameters are not listed among the arguments that the function takes. So I was like, okay, please go on, Wikipedia. What else do you have to say? So they say that the variable x designates the function's argument, but a, b, and c are the parameters. And you'll see here I've got a quadratic function, for those of you who remember some of your high school math. So you see f of x, and you'll see also that x actually designates the argument, whereas a, b, and c designate the parameters. I was like, wait a second. So in these two functions, one from math, one from computer science, a is the parameter, and bar is the parameter. I was like, whoa, that's really wrinkling my brain. So the way I like to explain it is the dog is a parameter, the football is computer science. So when the parameter hits computer science, its definition gets completely flipped on its end. So the takeaway from all of that is that parameters help define a function, and arguments are passed into a function. So here's the answer. The parameter is up at the top. It's the side, which is helping define shark, and then the string left is its argument. So all of that being said, we use the terms parameter and argument interchangeably all the time. So that was easy, right? Okay, next up is scope. When people ask me to talk about scope, I feel like this. I'm like, oh God, please don't make me talk about scoping. But first off, we'll start with lexical scoping. And we'll see that Google says lexical scoping, sometimes known as static scoping, is a convention used with many programming languages that sets the scope or range of functionality of a variable so that it may only be called or referenced from within the block of code in which it is defined. So just in that one definition, you'll notice that they've determined that lexical scoping is also called static scoping. Scope is called range of functionality, and called also means referenced. They also use the term scope in the definition of lexical scoping. So before you even can define lexical scope, you have to know what scope is. So let's break it down a little bit. Scope in the online etymology dictionary is an aim, purpose, object, thing aimed at, or mark or target, which kind of makes a bit of sense just because I know what scoping is in web development. But I decided to look it up on Wikipedia, and I see here that a scope is a part of a program that is or can be the scope for a set of bindings. A precise definition is tricky, see below. And I was like, okay, I guess I'll see below. Below, you'll see that in computer programming, the scope of a name binding, an association of a name to an entity, such as a variable, is the part of a computer program where the binding is valid, where the name can be used to refer to the entity. And because I already know what scope is, I understand this, and this definition makes sense to me. But imagine if you're coming to computer science or web development for the first time. That definition is not going to make sense. So I give that definition a C. It's okay. So scope again. I keep reading, and I see that the strict definition of lexical scope of a name or identifier is unambiguous. And I'm like, thanks a lot, Wikipedia. You're being condescending in your definition. But they say it's the portion of the source code in which a binding of a name with an entity applies. I was like, wow, that's one phrase. That's all I need. We've got scope defined. But then I keep reading, and it's been virtually unchanged from its 1960 definition in the specification of Algol 60. And I don't know about y'all, but I don't know what Algol 60 is, so I had to look that up. Algol 60 is short for the algorithmic language of 1960. It was the first language implementing nested function definitions with lexical scope. So we've had the definition of lexical scope since 1960, and we still have such a hard time explaining it. Okay, next up is lexical scope versus dynamic scope. Wikipedia says, lexical scope is the main focus of this article, with dynamic scope understood by contrast with lexical scope. So before you can define lexical scope, you need to know what scope is, and before you can define dynamic scope, you need to know what lexical scope is. Are you guys still with me? All right, so back to the online etymology dictionary. I look up what lexical means, and we see that it's pertaining to words. I was like, huh, that doesn't really make any sense to me. So let's keep going. Dynamic is pertaining to force producing motion and the opposite of static. And when I read that, I was like, oh yeah, that's like that first definition where we saw lexical scope defined as static scope. So static scope, dynamic scope, they're kind of opposite to each other. And then in Wikipedia, we see that for most programming languages, part of a program refers to a portion of source code or area of text and is known as lexical scope. And I was like, oh, that's where the term lexical comes from, pertaining to words. In some languages, however, part of a program actually refers to the portion of runtime or the time period between execution, and that's known as dynamic scope. And I keep reading, and I'm like, both of these terms are somewhat misleading. They misuse technical terms as discussed in the definition. It's like, wait, so what you just told me is wrong? And then I keep reading, and it says, but the distinction itself is accurate and precise. And these are the standard respective terms. It's like, wait, is it right then? Very confused. So I keep reading, and we'll see that lexical versus dynamic, in practice with lexical scope, a variable's definition is resolved by searching its containing block or function. Then if that fails, searching the outer containing block, and so on. Whereas with dynamic scope, the calling function is searched, then the function which called that calling function, and so on. I was like, oh, that makes a lot more sense to me. So all of that being said, this is a JavaScript conference where we use lexical scope, so who really cares about dynamic scope? So lexical scope to me is cats in boxes. Each of the cats is a variable. The box is a function. The orange cat can see the white cat, but the white cat can't see the orange cat. Okay, now recursion. So recursion on the online etymology dictionary is a running backwards or to return, or to run back. And it's like, that doesn't quite make sense for computer science, so let's keep reading. Let's check out Wikipedia. Wikipedia says that the most common application of recursion is in mathematics or computer science, in which it refers to a method of defining functions in which the function being defined is applied within its own definition. And it's like, wait, that's a lot of defining for just one definition. Let's keep reading. Recursion, specifically, this defines an infinite number of instances or function values using a finite expression that for some instances may refer to other instances, but in such a way that no loop or infinite chain of references can occur. So Wikipedia still has more to say. In mathematics and computer science, a class of objects or methods exhibit recursive behavior when they can be defined by two properties: a simple base case or cases, a terminating scenario that does not use recursion to produce an answer, and then number two, a set of rules that reduce all other cases towards that base case. And because I already know what recursion is in computer science, this makes sense to me, but if you're new to computer science, you probably would feel a little bit like this when you're reading it. Requisite Pokemon reference. And the way I like to define recursion is a function that calls itself. Some people might argue, but what about infinite recursion? And I'm like, well, that's still recursion. It's just you did it wrong. So I've asked other people to define recursion to me, and they always talk about the Fibonacci sequence, and I took math like a decade ago, so I don't remember what the Fibonacci sequence is. And when people bring that up, I feel like, whatever. Once, though, a friend actually referred to factorials to describe what recursion is, and I was like, wow, that's a really great, simple discussion of what recursion is. And everybody loves factorials because they have the cute little exclamation point. So when somebody explains recursion to me by talking about factorials, I feel a lot like this. Okay, next up is concatenation. Concatenation refers to a linking together or to link together a chain. And I was like, wait, whoa, this is from 1600, this circa 1600, which means that we actually are using this definition correctly in computer science. Yes, finally. But the real reason I wanted to bring this word up is because it's got the word cat in it. And this is my cat. Normally I would say that it's his birthday, but actually tomorrow is my birthday. And here's a recursive cat. All right, next up is instantiate. So instantiate in the online etymology dictionary basically just kind of says it's from an instant and then references itself and says instantiated or instantiation. So I decided to look it up on Google, and Google says, to represent as or by an instance, quote, a study of two groups who seem to instantiate productive aspects of this. And I thought, this what? As if this wasn't confusing enough in JavaScript. So when I kept looking up instantiation, I actually came across philosophy. And in philosophy, in predicate logic, universal instantiation, also known as UI, also called universal specification or universal elimination, and sometimes confused with dictum de omni, is a valid rule of inference from a truth about each member of a class of individuals to the truth about a particular class, individual of that class. And I was like, oh, that makes sense. I know that word, UI, that's like user interface, right? Just kidding. So basically what they're saying here is that all cats are mammals, and Fry is a cat, therefore Fry is a mammal. And we can actually write this out in code, unfortunately using prototypes in JavaScript. But basically what I have here is I've got prototype mammal, who has a neocortex, and then I actually have a prototype called cat, and I set the cat prototype to be a new mammal. And then I define and instantiate FryCat as a cat. And that makes Fry a mammal. So that's instantiation. Cool. Strangely, though, the online etymology dictionary, instantiation redirects to instantiate, and on Wikipedia, instantiate redirects to instantiation. So I'm not sure which form of the word is correct, but we've got a few of them. Okay, next up are a bunch of acronyms. CRM, CMS, and CDN. I always get these confused. So just for a reminder, a CRM is a customer relationship manager, like Salesforce. A CMS is a content management system, kind of like WordPress. And a CDN is a content delivery network, like Amazon CloudFront. Next is SaaS versus SaaS. If you're talking about one of these, can you please clarify which one you're talking about? Are you talking about software as a service like Salesforce? Are you talking about syntactically awesome style sheets, which is the CSS extension language? Next is DOM. This is Grotterdam, which is a cathedral in Austria. This is DOM, the American indie band. This is the DOM, which is a mountain in the Alps. And again, we see that word SaaS. I actually saw a guy wearing a shirt that said SaaS fee the other day, and I was like, oh my God, it exists. So there are lots of types of DOM. But the DOM that we're talking about is the document object model. Wikipedia defines that as a cross-platform and language-independent convention for representing and interacting with objects in HTML, XHTML, and XML documents. And I was like, yeah, that's kind of vague. So I decided to go to MDN, Mozilla Developers Network, another acronym, sorry, to look up what the DOM is there. And they define it as a programming interface for HTML, XML, and SVG documents. It provides a structured representation of the document as a tree, and it defines a way that the structure can be accessed from programs so that they can change the document structure, style, and content. I was like, oh, that makes way more sense. It's way more descriptive. And they even have a cute little drawing of the tree. Next is Gui and Cli, which I like to call Cli, because if we call it Gui, why can't we call it Cli? So when I hear Gui, the first thing I think of is ooey gooey butter cake, and I get really hungry. Or I think of a gooey duck, which is a bivalve that lives in the ocean. But this is how you spell it. And then when I hear Cli, I think of the painter Paul Klee. However, what we really know is that Gui is the graphical user interface, which were first introduced in reaction to the perceived steep learning curve of command line interfaces, or CLIs, which require commands to be typed into a keyboard. Lastly, I have Ajax, which stands for Asynchronous JavaScript and XML. Number one, who even uses XML these days? Number two, I figured out that the jQuery Ajax method has an option to set async to false, so you could be running SJAS, synchronous JavaScript and JSON. So in conclusion, when you learn these new terms, when you're new to computer science or web development, you hear them and you're like, what is this person talking about? I don't quite understand what they're talking about. And then over time, you just come to understand what that means and what that is defined for you. And because you can't quite identify what that process is along the way, it makes it really hard for you to explain what those things mean to other people. So when somebody asks you to explain a term to them, try not to be like this, or like this, and please be a little bit more like this. You got it, dude. Because it's super difficult to understand new things. And then I'm going to play this quick video. If I can find my cursor. So here we see some Tyke hockey players, and number 12 on one of the teams has fallen down. And she's like, I don't know what GUI is. Everyone around me is talking about GUI, and I just don't get it. What is GUI? And then other number 12 comes skating over, and she's like, let me help you. I'll explain GUI to you. GUI is the graphical user interface. And first, number 12 is like, oh my God, thank you. I understand now. So when we all act a little bit more like number 12. All right, well, I had a silly GIF from Adventure Time, but basically, we can party together in the JavaScript party land. I'll just drag over my notes. Yay!